Here we're going to look at topic 95, example 1, identify key features of exponential functions. So the question is, what are the key features of each function? And they're asking us to include the domain, range, intercepts, asymptotes, and end behavior. So here we state that an exponential function is any function of the form y equals a times b to the x power, where a and b are constants, and a cannot be equal to 0, right, because that'll cancel everything out. B must be greater than 0, and b cannot be equal to 1. If b is 1, you no longer have an exponential function. You would wind up having a linear function. All right, so we have two examples. I'm going to zoom out a little so we can see this all at once. And what we're looking at is two exponential functions with examples a and b. The charts and the graphs are already demonstrated for you. That's something we've done before, so for the sake of saving a little bit of time, I'm not going to go through finding each individual point and graphing these, but you should know how to type in some type of function on a graphing calculator or create a chart by hand and then be able to plot those points. So what we want to look at is at the bottom here, the domain, the range, the y-intercept, asymptotes, and end behavior. So in part A, my domain, really what we're looking at is this graph will continuously go to the left and continuously go to the right. So my domain, we could say, is all real numbers. Since this is just an exponential function, we're not looking at a specific scenario with a real life scenario or some type of word problem. We can just go right ahead and say all real numbers. And if you look at part B, I'm going to kind of go back and forth on these. This goes to the left, this goes to the right. So our domain is also all real numbers. Now, the range values. So our ranges, we're looking at the y values. Well, you can't exactly tell from this graph, but what's going to happen with these exponential functions is that they're going to approach the x-axis, and they're never going to quite touch it. So your range are all your values above the x-axis, which would be y is greater than 0. And that's the case for both of these. All right, it'll approach the x-axis, but it will not quite touch that. In line with that, and I'm going to skip to the asymptotes, is that since it goes towards the x-axis but never quite touches, it's kind of like a boundary. All right, we're going to look at that as an asymptote. So we can say our asymptote is y equals 0 or the x-axis. And again, that's the same for both of these. Okay. So these are kind of standard exponential functions. There are potential for reflections where your exponential function would be below the x-axis, but it's the same idea. It would still approach the x-axis just from below. Okay, so let's go back to the y-intercepts. Y-intercept is nothing new. You're just looking for where it crosses the y-axis. In this first example, that would be y is equal to 1, or the coordinate point 0, 1. And in the second example, we have 0, 5. You should have no trouble by now finding a y-intercept on a graph. Okay, and then finally the end behavior. This is a little bit new. The phrasing is going to be a little bit different than we've talked about before. But what we're looking for is as x approaches negative infinity, we want to know what does y approach. And as x approaches positive infinity, we want to know what does y approach. Okay, so what is that asking? We're looking for some question marks here. If x is approaching negative infinity, that's as my graph is moving to the left. So as this graph goes left here towards negative infinity, what is happening to my y value? Well, the y value is getting smaller and smaller. This is where it's approaching the x-axis. So in this case, your y value is going to approach 0. Right? So again, that's because your asymptote is y equals 0 or the x-axis. Your y value is going to decrease as you move to the left, as you approach x equals negative infinity. Now the opposite of that, as x approaches positive infinity, that's going to be as x moves to the right. So what's kind of going on there? Well, as we move to the right on this graph, the y values are getting larger and larger. So my y values in this specific problem are approaching infinity. And eventually they'll get up there because this is an exponential function. We've not capped the domain on anything. The end behavior for part B, so we're doing the same thing. As x approaches negative infinity, what does y approach? And as x approaches positive infinity, what does y approach? Not the best at making those infinity signs, but it'll do. So negative infinity in this example, we're moving to the left. As the graph goes left, notice how we're going up. So that means we're approaching larger and larger numbers. So y would approach infinity. So let's get rid of that question mark. Y would approach positive infinity. And then as x approaches positive infinity, meaning as the graph moves right, what is going on here? Well, the graph's getting closer and closer to the x-axis, which means my y values are getting smaller and smaller, and they are approaching 0. So just kind of going back through these 5 features or key features of the function, you should be pretty familiar already with the domain and the Y-intercepts. Knowing about the values being either greater than 0 or less than 0 sets up the asymptotes and the ranges pretty easily. And then the end behavior, you're just looking at what does the graph do when you're moving to the left and what does the graph do when you're moving to the right. So that's it for example 1, and in the next video we'll kind of apply this in a more specific context.